and logic. As you can see, you need to understand logical operators. You will be doing a lot of logic when you write your automation tests. And so you need to understand what each of these things are doing. Relational operators, as you already know in mathematics, is just like this, except that when you see a double equal in coding means what? Equal to. In mathematics, it's just one equal sign, but here in Java we have x equal to y is what means equal to. That is, x is exactly y. So x not equal to y is always written like this. X greater than y is always written like this. X less than y always written like this. Now x greater than a minute please. Okay. Okay, so we have x less than y, which as you can see it here, x greater than or equal to y, x less than or equal to y. Now, I explained a little bit about the if else statement the other time. Let me explain it better. So we call the if else statement a conditional statement. Why? Because there is always a condition that must be fulfilled. So how do you write that? You have your open and close bracket, just like the way you write your method. After your method name, you have what? This open and close bracket before your block of code, which is this. All right. Now, we have our condition usually within this bracket. So you say x greater than 0 or whatever the condition is. Here, the condition is that x must always be greater than 0. All right. Now, s is not greater than 0. That is, this condition is not fulfilled, then this statement will not be executed. Let me come again. X greater than 0, this condition must always be true. If this condition is not true, then the block of statement, the statement within your block of code will not be executed. Just like we have it here. If we assume that x is 5, then you can say 5 is greater than 0. And of course, 5 is greater than 0. It means that what will be printed to the console is what? X is positive. All right. Now there is statement that is if else. The reason we have if else is the condition has to fulfill other conditions, right? Now, if x is not greater than 0, for example, if it is -1, right? You know this will not be executed. That means it will leave the application hanging, right? And in testing, you don't want to leave it hanging. You want to consider every odds, the positive test cases, the negative scenarios, the edge cases, the gray areas, and so on. And so you have to give everything what? Conditions. Now look at this. We have if this condition, see, S has been introduced here. Now, if this condition is false, it is going to jump to this block of code. All right. Now, if our S is 5, like I assumed earlier, and by the way, this is not percentage as it is in mathematics. This is modulus. So modulus means that when you divide a number by another number, the remainder is the value of the modulus. When you divide a number by another number, the remainder is the modulus. So the remainder is what we are considering here. If our x is 5 and I divide 5 by 2, then the remainder, which is 1, is what you will consider. Is 1 equals to 0? No. Is 1 equals to 0? No. That means that this condition will not be executed. Why? Because this is already false. What do you think will be executed? System.out.println, that is S is odd. You know S is odd, right? Because we have said S is 5, right? Now, if you divide 5 by 2, you will get 2, remainder 1, right? Okay. That means that 1 is not equal to 0. That means that you are going to print that S is odd. By the way, if our X is 4 here, right? And you say 4 divided by 2, 0. You know, the 0 you get here is also equals to 0. That is, 0 is exactly equal to 0. Then it means that it is going to consider this statement. Why? Because this condition is true. This condition must always be true for the first statement here to be executed. That is the rule. So you have X is even. All right. So this is how if else work. Look at other conditions and see how it is executed. So that is if else. I will quickly go through all of these statements, and then we will have 1 or 2 exercises in this area. Now we have chaining and nesting. Somehow, sometimes some people mix the two together. They are not totally the same. They are different. Now, chaining is by a series of if-else statements. So, an example of chaining you can see here is this one here. So, we have if this, else if, else. So, we'll continue to have if this, else if, else if, else if, until you get to the last else. All right. So, these chains can be as long as you want, although they can be difficult to read if they get out of hand. One way to make them easier to read is to use standard indentation as demonstrated in. Okay, so by the way, when it comes to indentation, in Java, it's a little bit different from Python. You know, in Python, indentation is very like critical to execution of code, but in Java, it is not so. But if you put standard indentation, that is, if this your if else follows each other, then it will be easier for you to read the code. All right. So notice that the last branch is simply else, not else if. So at this point in the chain, we know that S is not positive and S is not negative. There is no need to test whether S is 0 because there is no other possibility. So when you get to this last part, there's no other possibility, there's no other condition. If the user is a first time user, if the user is a returning user, if the user is a VIP, if the user is what other important something entire personality, if the user has the this number, if the user, so all the condition, and then when you now get to the last one, there's no other condition left. All right, you don't care about whatever condition is left in the last one. You just say so far is a user, right? So you say else do this. The user cannot be identified or whatever. System out or print, the user cannot be identified. So sometimes when you are writing those kind of things, you make use of if, else, and all of that, right? But as for nesting, look at the structure of nesting, right? And compare it to what you have with chaining. So you have your else if. Now, this your else, which is the last one in our chaining, comes first. So we have your else, and then you now say if else, right? And then your else, and then your if else, and so on. So now we have the first one. Let's look at it together. This one says if this condition is true, print S is positive. So let's give our S a value. Let's say our S is 5, like we have been using it before. If 5 is greater than 0, then it will print X is positive. All right. Then else, if 5 is less than 0, it does not concern us. Else, it still does not concern us. Now look at this. If S is greater than 0, else is positive. Let's assume that our S this time around is not an odd number, is an even number. Let's say S is 4. Now, if, or let's choose a negative number. Let's say our S is minus 5 this time around. So 5 is greater than 0? No, right? So it's not going to consider this first statement. Then 5 is greater than 0. It will not consider this. Why? -5 because it is false. This must always be true, right? -5 is greater than 0. No. So it jumps to else, and then it considers this again. Is 5 less? Is -5 less than 0? Is it? No. Then it will come here. Uh, okay, so it's going to come here. No, the signs are different. Sorry, I didn't get it. This is greater, right? -5 greater than 0, right? Is -5 greater than 0? No. Then it comes here. Is -5 less than 0? Yes. I didn't see this one. See this less is even from the one that is here, greater. So somehow the condition has changed here. Now, else, if -5 is less than 0, is -5 less than 0? Yes. So it's going to consider this. But however, if our s is not -5 or +5, then it is what? 0. Then it can jump to this value here. Let's do the same for this place. Let's assume our x is -5. If our x is -5, what do you have? -5 greater than 0. -5 greater than 0. Is -5 greater than 0? No. It is not going to consider this statement. It will move to the next statement and read. Is -5 less than 0? Yes. Then it's going to do what? It's going to print as a negative. And then what will happen? It will not consider this. Now, if it is 0, what happens? It is not going to consider this. It's not going to consider this. It's just going to jump to S0. So now that is how if else conditional works. Chaining and nesting. All right. Chaining and nesting, that is how it works. I review this one after the other, please. There is also something called the switch statement. Switch. All of these things are used for making decisions. There is this testing technique in QA that makes decisions. Can anyone remember that? Decision making. Decision table. I've said it already. Okay, so there is what? Decision table. And when you are making decisions in testing, you have what? Positive, negative, negative, positive, true, 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 false, false, true, false, false, right? And all of that. Now, some of these statements we have here can help you also make that decision when it comes to what? Automation. All right. You use your logical statement to do what? To make decisions. Give me 2 minutes, please. Okay. So we have the switch statement here. If you need to make a series of decisions, chaining else if block can get long and redundant. That's one negative part of it. For example, consider a program that converts integer like 1, 2, 3 into words like 1, 2, 3. Okay, so we have something like this. You want to convert integer 1 to 3 into words, and then you want to switch from 1 to 2 to 3 to 4 and then to an unknown number. This chain can go on and on. Why? Because we have 1 up to infinity. And this method of if else will never work for it. So what is the another alternative you can use? Another alternative you can use is the switch statement. Now the switch statement we say switch number. If the case, not the case, there's something called case. There's a keyword in switch called what? Case. For case 1, you say 1 equals to this. For case 2, for case 3, and when it comes to default, it means that now we are not sure of what the answer is. Anything goes for this condition that is unknown. break. So that is how switch works. Switch is not also efficient if you are talking about this particular you will see more efficient statement as we move on, more efficient logics as we move on. Now, here is another switch that says food. What kind of food? Apple, banana, cherry. If it is a case of apple, banana, cherry, print fruit, break. If it's a case of asparagus, broccoli, or carrot, print vegetable, break. Right? It could also help to categorize, right? To categorize your conditions. All right. Although switch statements appear longer than chain else if block, they are particularly useful when multiple cases are grouped together. So you can actually group them into different sections using what? Switch. All right, that is all for if else and the switch statement and chaining and nesting. Chaining and nesting ask for if else statement. But look at logical operators. So we have talked about greater than, right? Less than, and equal to. Now, those are our logical operators. Now, is it possible to now chain conditions within our what's the name now? Within our if else statement? Like, for example, here we have condition x equals to 0 and condition y equals to 0. If you have this condition and you have this condition, this takes us back to the decision table again. If we have a true and a true, we always have a true, right? What happens if we have a true and a false? I've said it before. The condition for you being in this class is that you have a perfect understanding of manual software testing. Okay? It's going to help you, it's going to sharpen your automation skill set. All right. Now look at it this way. We have AND operator, we have the OR operator, right? And we say you can use the AND operator, you can use the OR operator as condition, combine it together as just one condition. And now there's another one called not, the exclamation mark. So not means that it is not true, all right? And by the time you remove not, it means that it is true. That is, the condition must always be true. Now, if you open a bracket, see, it's true if x is not greater than 0. The parentheses are necessary in this example because in the order of operation, not comes before the greater. Yes. So, let's look at this example I was talking about. The first one says, if x is exactly equals to 0, and say, okay, don't let me use and. There's no hand in this one. Now, there is a block of code of if. See, it's starting, what will I call it now? Parenthesis, and it's closing block parenthesis. It has another if within it that has its own start and end parenthesis. Now look at it. Is x equals to 0? If this condition is true, then it should execute whatever statement is within it. And if y equals to 0, you should do what? Execute what is within it. But what do you think will happen first? It will come here and say y equals to 0, print this out. And then it will go back to this condition. Now, this as it is not effective, it's not efficient unless it is what? Combined. That's the essence of combining what? Conditions. Now, because what we are trying to say here is to check the two conditions at the same time. So instead of now writing different lines and occupying all of the spaces in the system memory, it's better to just have just 2 lines of code. That is more efficient. So what do we have here? We have x is exactly equals to 0 and y is exactly equals to 0, right? So we want to consider this condition, and both has to be true for us to be able to execute the statement here. So you check the condition. Let's say that our x is 1. Is 1 exactly equals to 0? No. And is y exactly equals to 0? No. So we have a false first. All the same, this is going to be printed out, right? Because false is false. True is true. But if one of the condition, right? If one of the condition is true and the other one is false, what do you think you should use? The or operator. Likewise, the or operator can simplify change if statements. Since the branches are the same, there is no need to duplicate that code. Look at this, for example. So we have either x or y is 0. What we are trying to say is that only one of the conditions need to be true or false. All right. Now, using the same example of 1, is 1 equals to 0? No. Is y is okay? So what did we call y? Okay, let us say y is 2 or something. So if x, which is 1, is it equals to 0? No. Is 2 equals to 0? No. So you say either x or y is 0. What we are trying to say is that the condition here and here, either of them has to be true or false. But for here, the condition here has to be what? Both x and y are true, or both x and y are false. However, for all we have what? Either x or y is what? True, or either x or y is false. All right. I won't say much about the Morgan's law. For the mathematicians among us, they probably already understand the Morgan's law. When you open your not bracket and when it is closed, it means different things. Okay, we have Boolean variables. We talk about this. The concept of Boolean says true or false. Let's establish that. True or false, that's what we call Boolean. So when you name a variable, when you are declaring a variable that is Boolean, you can say Boolean that variable. It means that you are expecting that variable to either be true or to either be false. All right. So I think, is there any example to back this? Okay, yes, there's an example here for Boolean methods. So we have seen different writing different methods that takes in parameters. Now this one also takes in parameter. It takes in a parameter integer. However, because we expect a Boolean return type, what happens? We have a Boolean method. Public static Boolean is single digit. This is the name of the method. Okay. So we have public static, the return type, and then what? And then the method name, and then this is the parameter it takes in. All right. Now we say the next thing you see here is what? An if condition, if else condition. And the condition is combining two conditions together. It says if x is greater than minus 10, and if x is less than, these two conditions has to be true, then return true. All right. Now look at it very well. If we say our x is 5, like we have been using, is 5 greater than minus 10? Yes. Look at this. Is 5 less than 10? Is 5 less than 10? Yes. So does that mean that this condition is true? Yes. So it's going to return true. Right? Let's assume that we choose a value that is negative. If we say minus 5, for example, is minus 5 less than minus 10? Right? Is minus 5 less than minus 10? I mean, sorry, greater. Is minus 5 greater than minus 10? Yes, right? And is -5 less than -10? I mean, is -5 less than 10? Can someone do this mathematics for us? I'm not the only one in this class. So let's assume our x is -5. Listen again. We want to check this condition -5 against this condition. We want to check s is -5 against this condition. So we say -5 greater than 10. Is -5 greater than 10 than -10? Is -5 greater than -10? Yes. And is -5 less than 10? Yes. So it means that these two conditions are true. If they are true, what happens? You return what? True. Else, even if one of it is wrong, even if it is this one that is wrong and this one is true, you will still return what? What? False. Why? Because you have and in between it. Let's see what this gives us on IntelliJ. All right, so I have my IntelliJ here. I will call this control. I just call it control. Okay. So yeah, is it if else? We are still in the if else statement. Okay, so I have something like this, right? Let me write my main method here. Call it somebody is asking you to print anything. Okay. This. You know what this statement is saying? This statement is saying that our hex is 5, 10, -5. Now, let's look at the -5 I mentioned earlier. We said if our x is what? -5. That is, if you say x is greater than, if -5 is greater than -10, and -5 is less than 10, return true. Okay? So what do you think this will return? What do you think this will return if, let's check the last statement here. If x is -5 and if x is 5. Okay, so let's execute this. Let's execute this. Okay, see what we have. So we have true. So we were correct. We used condition 5 and -5, right? We said if 5 is greater than -10 and if 5 is less than 10, return true. And if it is -5, if -5 is greater than -10, true. So if these two conditions are true, then what do you have? You return true. Now, if we use 10, let's look at that 10. 10 greater than -10, is it? No. Yes, it is. Is 10 greater than -10? Yes. Now, is 10 less than 10? No. 10 is equal to 10, but not less than 10. So this in itself is already a very wrong condition. It's false, right? This is false. Which means that it makes this entire thing false. So it's going to return what? False. And that is why we have false for here. So that is how you understand the and. So this and condition is saying this and this has to be true for it to be true. And if you have your or, it's saying that either this or this should be true for your statement, for your return to be true. So look at this again. So we have been able to establish this. Now assume that it is or. Did they put or here? Did they put or here? So um Validating input, validating input, validating input. Okay. This is talking about the scanner again. We talked about scanner last week, did you not? We talked about you initializing your scanner and then using your scanner to take input from the user. Right. I think we did something about that. Okay. We are looking at our time. We need to finish. We need to finish statement and loops and all of that today, so that we can start looking into the real deal. The real deal is it's not even here. The real deal should be designing classes, mutable object, extending classes, and reusing classes. So we still have a lot. However, we will touch a little bit on these classes now, and then we will now do more of it when we start writing our test cases. All right. So with that, we'll be able to cover up. So we have the while statement. The while statement is it belongs to the category of loops and strings. We talk about if and the switch. The if else and switch. They belong to a different category called logic, conditionals, and logic, because they help to make decisions. But there is another one called what? Loops and strings. And within these loops and strings, we also have different kind of loops. The first one is the while loop, and the second one is the for loop. All right, let's see how it goes. So we have the while statement. The while statement always have its condition first. So we say, while this condition is true, print this statement. Like what you see here. While this n is 0, so n is, while this n is 3, n is 3 has already been assigned, 3 has already been assigned to n, so n must always be 3. So you will now look at the condition. Is 3 greater than 0? Yes. What should you do? You should print 3. Not only should you print 3, you should also print what? You should also go to this condition and say 3 minus 1. So the first thing it will print is what? 3, which is the initial value. The second thing it will print is, let's do this. Let's see how this gets executed. So we have okay, this is print statement, right? This is print statement. So we have, well, not if else. What we are doing now is the while, the while loop. So for this while loop, is this thing even writing into where it's not supposed to write? Okay, I can't just write this without a method. All right, nothing will happen without a method except I put it within my main method. Okay, let's write another main method for it. Okay, good. So I'm going to write another main method for it and put this within it. Okay. Why is this one not having the I? Okay, so that we have that now. We have that now. So we say our let's look at it very well. We have our n equals to 3. And the concept of loop means that you continue. You know, the way your onion bulb is, where you have something nested, another thing against another bulb, against another bulb, and against another bulb. There's always an inner of an inner, right? Now, loop is something like that too. It means that whatever the value is at the initial is going to affect the next value, and this next value is going to affect the next value, and this next value is going to affect the other next value. So we are saying that our first value for this loop is 3. Now, is 3 greater than 0? Yes. So it's going to print 3. That's what I put here. Now, the next thing is that it's going to look at the next thing and check this condition that is here. What's our value right now? 3, Abby? To say 3 minus 1. And then you will get what? 2. And then it will look at it again and say 2 minus 1. So far, the value is still greater than 0. Now, let's do it again. The first value is 3, right? Now, 3 minus 1 gives us 2, right? The next value is 2. The next value is 2. 2 minus 1 gives us what? 1. Is 1 greater than 0? It is still greater than 0. So it will continue. 2 minus 1 equals to 1. Is 1 greater than 0? Yes. Right? So it will say 1, 0. Now we are on 0. Is 0 greater than 0? No, then it will stop. And then it will come here and print blast off. Now, this is how it will execute. It will print 3, print 2, print 1, print 0, and then blast off. That's how it will execute. All right. Great. We have 3, 2, 1, blast off. That is what loop means. It means that you have to keep checking the condition. When you check the condition, you execute. Then you check the condition, you execute. Then you check the condition, you execute. And you keep checking the condition. Now, the flow of execution of a while statement is as follows. Look at it. We have this condition here called Boolean, and then we are saying that if this condition is true, go to the statement and do what? Execute. After you execute, go back to the condition again. If this condition is true, go to your statement and execute. After you have done it, go back to the condition again. If the condition is still true, go back and execute. Now, if when you have finished executing and then this one is false, what will happen? It will just stop. Because why? Because the condition is no longer true. So it will stop. You see that this arrow here is not connecting to any other thing, right? Because now the condition is false, it will have to stop. That is the flow of execution for a while loop. Now, if you want to do the same thing in a for loop, we'll talk about decrement and increment. So look at a for loop. Look at how a for loop operates. Yeah. So a for loop, we have its condition inside here like this. Now, if the condition is true, it will go to the statement and execute. And it will not only execute, it will now update. There's something called update, also called step. Now, see, this is how a for statement is written. A for loop is written. Just like a while that is always inside a bracket, you have a keyword for, and then the condition within the bracket, and then your block of code. Now, we have a starting or initial value called that always starting as the first condition for a for loop. And then the condition is always followed by the condition. And then the last thing you will see is the step, all right, or the update. Call it the step or the update. Now, let's say it again. The initial value, the condition, and then the step. So, what does all of these things mean? Now, look at it this way. We have a value of I called 2. And we are saying that 2 is less than or equals to 8. Is it? Is 2 less than or equals to 8? Yes. So this condition is true. So the first thing that will be printed is what? Your 2, comma, right? Concatenated, comma. Now, you will come back to this step. And what will happen? We are saying that you should add 1 to the initial value, which is what? Which is 1. Okay, I didn't explain the concept of increment and decrement. Let's go back to the increment and decrement so that you can understand better. Increment means add one. Decrement means subtract one. Very simple. Increment means add one. Decrement means what? Subtract one. So when you see I plus plus, it means that add one to I. And when you see I minus minus, it means what? Subtract one from I. All right. Now there is another thing called I plus equal. When you see I plus equal, what we are saying is that add one to I, all right, and make it equals to what? To 2 or to any other value. Or if you see subtract equal, it means subtract 1 from the initial value here and let it be equals to something. All right. So it's as simple as that. Now, when you see something like this, oh, give me 2 minutes, please, guy. Oh, sorry, guys. Okay, so I was explaining the increment and the decrement. So I said when you see something like this, I plus equals to 2, it means add 2 to I. Now, let's explain it. I plus I plus equal 2. What is this thing giving me? Let's comment it out. Okay. So what you are trying to say here is that if your I is 1, so what you're trying to say here is that if your high is 1, if your high is 1, if your high is 1, then you can say 1 plus 1 is equal to 2. Okay. Now, because when you see there's something called I plus plus, which is increment, somehow this thing just find a way to, still going to comment it out. Okay. So when you see I plus plus, it means what? It means you want to add a 1 to what? To I, to the initial value of I, to give you what? 2. So we have something like this. So you said your I here is 2, right? You now check this condition and you say your 2 is less than or equals to 8. Is it? Yes. Now, why this condition is true, print out 2 plus that's concatenated with a comma. So what will you print first? You will print your 2 first, right? Now, you will now bring your 2 here and you will add, you bring your 2 here and you will add 2 to it. Add 2 to I. Oh, yeah. So you will add 2 to it. So when you have, so this one here means add 2 to I, right? Add 2 to I. But when you see, when you see I minus equals to, it means subtract 2 from I. If you see something like this, I multiply equals to 2, it means multiply I by 2. And if you have this also, you have, okay, wonderful suggestion. I like this. Okay. So this means, as you are looking at it, this also is another aspect that can I minimize it? I'm not minimizing it. Let's see. Yeah, there's something called this, and then there is. Okay, so let's stop here. All right. So we have so when you say the plus plus before I, it's just the exact opposite of the I plus plus. The I plus plus says that add 1 to the initial value of I, right? You add 1 to the initial value of I. But here you do what? You add, you have 1 and then you add I to it. How do I explain that to you? And then you have, okay, so maybe when we have an example in looping, we can explain this better. But when you see a plus or equals, it's very direct. Now, what if this value here is not 2? What if we have 3? It's the same principle. So the same principle, we say add 3 to do what? To I, and so on. Now, we have something like this here, a condition. Our initial value for I here is 2. So we say 2 plus 2 to give us what? 4. Then you will now check that 4 against this condition. Is 4 less than or equals to 8? Yes. What we have to print out 4. So don't forget that it has print out 2 before now, comma. Now it will print out 4, right? And then it will now check, go back. It will go back here and check for, okay, that's printed out 4. Now, what is the next thing? The next thing is that the value of I now is 4. So it's going to say 4 plus 2, which is what? 6. Is 6 greater than or equals to 8? I mean, less than or equal to 8, yes. So to print out 6. Now the value of I now is 6. It will come here and say again, 6 plus 2 is what? 8. Is 8 less than or equals to 8? Yes, 8 is equal to 8. So what we happen is to print what? 8. Right? Now that the value of I is 8 now, to come here and say 8 plus 2 is 10. Is 10 less than or equals to 8? Number 1, 10 is not less than. Number 2 is not equal to. So the condition is false and then it will stop. So when it stops, it will jump to this next line and say, who do we appreciate? Print this out. Yeah, as you can see. So we have 2, 4, 6, 8. Who do we appreciate? So that is how it checks the condition. So that's the concept of increment and decrement. So when you see increment and decrement here now, this one we're trying to explain. When you see I plus equal to 2, what you're saying is that you want to add 2 to the initial value of I there. What's the initial value of I here is 2. So we are saying that we want to add 2 to 2, which is 4. And now you check the 4 condition against this condition. Is 4 less than or equals to 8? True. What do? You print. So you see, they are trying to do the same thing. This is the same condition. But right now, we have it in a for loop instead of the while loop. Just imagine. So the same condition, we say print number 1, the initial value of I, which is 2. So 2, comma. Now that we have 2 plus 2, we have 4. Is 4 less than or equals to 8? Yes, comma 4. Then we have 4 as I now. So 4 plus 2, which is 6, is 6 less than or equals to 8, true. Then it will print 6. Then now the I now is now 6. And we say 6 plus 2 is 8. Is 8 less than or equals to 8? 8 is equals to 8. To print 8. And then 8 plus 2 will give us what? 10. Is 10 less than or equals to 10? No. It's not going to print it. It will jump to the next line and say, who do we appreciate? So it's going to print exactly the same thing that it's printed for this, except that the flow of execution for loop is different. How is it different? If you compare the for statement to the while statement here, you see that we have the initial value being stated first, and then the condition alongside with a while. See the while, the condition, and there is no step value. The step value is assumed to be an expression within the block of code. Okay. But as for the for loop, we have everything in just the bracket, all of the conditions, saying that this is the initial value. All right. This is the initial value. This is the condition. And this is what is the step. All right. Or the update, continuous update to your initial value. Okay. And so when it executes, when you have your condition, if the condition is true, right, it goes to the statement, it's executed. Now, after it has got to the statement, it will now update the value of the initial value. It will update it. And if it updates it, it will check the condition again here. Is the condition true? It will print. Then it will update. Is the condition true? Is the condition true? It will print, right? Then it will update. And that's how it goes. But the moment the conditions becomes false, there will not be any statement. So it's just going to stop. All right. So we have our while and our for. Which of the loops do you think is most efficient? As you can see, like I mentioned earlier, the most efficient here is the for loop. As you can even see, it doesn't even take more than how many lines of code do we have here? Is this 3? This one has 5 or so. Anyway, the for loop is the most efficient. We also have nested loop. Just like we had nesting in the if else statement, you already know that when you have a for inside the for, you have a if inside another if. It's called nesting. So we have this for loop inside another for loop, right? Both loops have their conditions. So what do you think will happen? We want the two conditions to be executed, to be true, just like our if else statement. However, if you look at this very well, you will discover that it's going to be multi-dimensional. Like this is how it's going to print, because we have different what will I call it now, variables. We have variable x and we have variable y, right? We have variable x, and variable x condition will be checked separately. Variable y condition will be checked separately. So at the end of the day, we will end up with something like this. So x values like this, y values like this, y in vertical, and x in the horizontal. So let's read what this condition is saying. This condition is saying when x starts from 1 and it has a condition x less than equal to 10, is 1 less than or equal to 10? Yes. Then start incrementing by 1 because you have x plus plus, that means you had 1. So the first value is 1, the second value is 2. If you increment by 1 again, you have 3, then you have 4, then you have 5, 6, 7, 8, 9. When it gets to 10, check the condition. Is 10 less than or equals to 10? Yes. All right. Then when you get to 11, is 11 less than or equal to 10? No. All right. Now, that is not all. When it gets to 10, you still have to check. You have to check for this condition too. You will do the same thing, 1 to 10. So the very first horizontal and vertical are going to be number 1 to 10. Horizontal 10, horizontal 10, vertical 10, that is x value 1 to 10, y value 1 to 10, because this y also says the same thing. Y equals to 1, then you had 1, 2, and then 3, and then 4, 5, 6, 7, 8, 9, 10. Now, after that, you check this condition. It says system out of print f. Now, talking about print f is a formatting style, right? Did we talk about it? I'm not sure. But if you have read some of the chapters before now, you will have seen it. So this is saying that we have to print it in a is it 4-dimension or is it 2-dimension? I can't quite remember. But this is the format condition. And then this is the expression we are to evaluate. Now, what this thing is saying is that you have to multiply the value of x by the value of y. So the first value of x here is 1. And the first value of y here is 1. If you multiply 1 by 1, what do you have? 1. 2 by 2, 4. 3 by 3. All right. So 1 by 1, 2. 2 by... You multiply it. I think you understand. The first we have here is what? Let's comment it out in our IntelliJ so that it will be clearer. We have... Okay, so I will just put it in the comment, not like just so that we have. So yeah, the first set will be this. This is our x value. Let's say this is our x value in horizontal. Then we have our x. We have our y value vertical. So this is going to be y, and then vertical. All right. So if you evaluate this, you check this condition, you discover that this condition is true until it gets to 10. This is also true until it gets to 10. And this is our y condition. So let's assume this is vertical, not horizontal. If we are writing it 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, just like you see in that textbook. This y should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 down. And then this x is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 horizontal. Anyway, I've written vertical so that you will understand. Now, what we are now saying is that you pick the initial value of x, 1, and you multiply it by initial value of y, 1. All right. So multiply 1 by 1, then you have 1, right? Then you pick 1 again, multiply it by, pick 1, which is x, multiply it by 2. What do you have? 2. 1, multiply it by 3, you still have this. That's the first thing. The second one is going to be what? You pick 2. You pick 2. Multiply it by 1. So this is going to be 2. Yes, it's going to be like this. So you're going to pick 2 multiplied by 1, 2 multiplied by 2, 2 multiplied by 3, 2 multiplied by 4, 2 multiplied by 5, 2 multiplied by 6, 2 multiplied by 7, 2 multiplied by 8, by 9, and by 10, which is what? 20. Right? Now, you are not stopping there. 3 multiplied by 1, right? You put 3 multiplied by 1, multiply by 2, multiply by 3, and then you pick what? Now you pick 4. Multiply by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you pick 5. That is how you keep doing it. And then you see, this is 7, right? Then you have 8. 8, and then you have 9, and then you have 10. And this is where it stops, because now you have used the whole of x, and it has to be the value of x multiplied by the value of y. All right, so if you look at this now, you discover that it looks exactly like what we have in the textbook. Right. So we have 1, 2, 3, 4, 5, 7, 8, 9, 10, 1, 2, 3, 4, 5, 7, 8, 10, and then you have the multiplicative index like that. Okay. The format specifier percentage 4D displays the value of x multiplied by y padded with spaces, so that, yeah, okay, that's what it means, padded with spaces, so that it's 4 character wide. Doing so causes the output to align vertically, regardless of how many digits the numbers have. Okay, so what makes it into this format is this percentage 4D, which is the format of the output that you want. Is usually used for floating point numbers. Please read up on that. While loop, string iterations, index of method. Okay, let's talk about index of method. Okay, so we have an example here. Banana. So we mentioned the other time that each of the value you assign to a variable represents a space in the memory, in the system memory, right? So if you have a string, for example, a variable string called fruit, and then you call it banana, a string called banana. Now, banana has 1, 2, 3, 4, 5, 6, 6 characters. It has 6 characters, and each of these 6 characters has its own index. All right. So I call a memory diagram for a string of 6 characters. So it has its own index. Now the first index is usually 0. So we say B is of index 0, A is of index 1, all right? N is of index 2, A is of index 3, N is of index 4, and then A is of index 5. However, there are 6 of the characters. So at the end of the day, we will say the length of banana here is 6. Why? Because it has 6 characters. However, its last index is what? 5. Its last index is 5. Its length is 6. So when you want to calculate the last index of something like this, you say n minus 1, meaning that the last value minus 1. I mean, sorry, meaning that meaning that its length minus 1. Okay, so what is the length? What is the number of characters for fruit here? 6. When you subtract 1 from 6, you have 5. 5 is the last value of the index, is the last index. So you want to know the last index, you have n minus 1, which is actually the length, minus 1. Okay, so that is how you know index of. So when you want to call index of for these fruits, you want to call this index of method the string method. You want to call it on fruits, you have to check which of the characters you are talking about and its index value. We are talking about A here, and then its index value is what? 5. A, its index value is 5. We say that A, comma 5 returns what? 5. If the character does not appear in the string index of returns -1. If the character is not here to return -1, since indexes cannot be negative, this value indicates the character was not found. Okay? So that is how you call index of. All right? Uh, Every other thing you can read up on your own, very simple. But the most important thing in this page is the while statement and the for loop statement, which we have looked into extensively. So it's just basic concept, basic concept. When you start using it for your coding, you will understand it. I mean, for your automation, you understand it better. However, I will not ask you to stop here. You need to go home and please practice. Practice. There is nothing you are looking for in this textbook that you will not find. It is there. So if there is an assignment, I mean, if there is an exercise that you are working and is looking difficult, you read the textbook again over and over. I'm telling you that all of the things they are asking, they've already explained in all of the examples above. All right. This example, for example, exercise 1. Can you prove that this loop terminates for any positive value of n? So we have our main method here. It calls the method loop. And loop is taking in an integer n. All right. And what is our n? Our n is int I equals to n. We are saying that our n is an integer. Okay. Now, so when we have int I equals to n, we say why I is greater than 1, print I. All right. While index is greater than 1, print the index. Now, this index modulus 2 has to be equals to 0. That is, it has to be even or so for it to be true. And if it is true, then execute this expression. All right. Now, if we are saying that our n is 10, all right, then we can say y index is greater than 1, yes, which is true. Then we can print 10 as the first number, and then we can now say 10 modulus 2. 10 modulus 2 is 5 remainder 0, right? Is 0 exactly equals to 0? Yes. Then we can say that we can say 0 divided by 2. That is no. Then we can say, sorry, what can I say? You can say 10 divided by 2. When you divide 10 by 2, what do you have? 5. So that will be the next value. So you have your 10, 5. And then now that you have 5, you divide 5 by 2. Okay? You divide 5 by 2, and then you have no, before you divide 5 by 2, you go back to this condition. Is 5 greater than 1? Yes. 5 is greater than 1. What do? You print out your 5. Then you go to your if and say 5 modulus 2 equals to 0. 1, are you saying 1 is equals to 0? Because you say 5 modulus 2, that is remainder 1, right? Is 1 equals to 0? No. Is it? No. 1 is not exactly equal to 0. No. So what will happen? It will jump to else. And when it jumps to else, it will just say this new value of 5, which is 5, plus 1 is what? 6. Now, the new value of I is 6. If you go back to the condition, is 6 greater than 1? Yes, 6. Then print 6 and then check the value. Is 6 modulus 2? 6 modulus 2 is equal to 0, yes? Yeah. If you divide 6 by 2, you have 3 remainder 0. right? So that means that you have here your 6 divided by 2, which is 3. So we print 3, 10, 5, 3. Okay. So now you have I equals to 3. What will happen again? You go back and check, is 3 greater than 1? Yes. 3 modulus 2 is 1, right? 1 equal no, it will move to else. And then it will add 3 to 1, which is 4. Now it's going to print 4, right? However, 4 is 4 greater than 1, yes. Then 4 modulus 2 is what? 0. 0 equals 0. Then you have 4 divided by 2 is 2. And then like that. Let's see how our intelligence will execute this. I'm curious. Okay. So we have yeah, for loop. You already know. So I have okay, I still have a main method here that I've not commented out. Now I have a main method here and I have a loop method here. Okay. Now let's execute this code and see which prints first, which next, and next. Right. Okay, so we said our n is first 10, and then 5, and then 6, and then 3, and then 4, and then 2. Yes, got it. Now, it's the same explanation that I gave the other time, that your initial value for n here is 10. It means that you are going to compare 10. Is 10 greater than 1? Yes. What do you do? Print out 10. So you have 10 here. Now you check the condition. 10 modulus 2 equals to 0. Is it? Yes. That is 10 divided by 2, remainder what? If 10 divides 2, you have 5, remainder 0. That means 0 is exactly 0, right? So you have your 5, right? Then you now say 5 divided by 2. 5 equals to 5 divided, no, sorry, say 5. 10 divided by 2 will be what? 5. All right. Now, we are not considering else yet because now the value is 5, Abby. Then you go back and check, is 5 greater than 1? Yes. Then print 5. And then if you say 5 modulus 2, what happens? 5 modulus 2 is 1. Is 1 equals to 0? No. What happens? You now bring that 5 to else. And then you now say 5 plus 1, 6. Now that you have I is equals to 6, you go back again and say, is 6 greater than 1? Yes. Then you print 6. And then you say 6 mod 2. So your 6 mod 2 is what? Exactly 0. That is 3 remainder 0. So you have 3 divided by 2. But you know it's print statement that we always been printing. So it's the print statement that we print all of these things out. All right. So we have where did we stop? So we said 6, right? So the value is what? 6 mod 2, which is true, right? Now we have 6 divided by 2, which is what? 3. Now the new value of n is 3. Is 3 greater than 1? Yes. And can you print it? Yes. That's how you get to print 3. Now, but you still have to continue with the condition. 3 mod 2 is what? 3 mod 2 remains 1, right? So 1 is not exactly 0. It will come to this condition and say 3 plus 1, which is 4, right? Now that we have 4 here, then it will now go back and come here and say, is 4 greater than 1? Yes, print 4. That's how you get your 4 to the console. Right? Then you now say 4 more 2 is 0. Because 4 divided by 2 is 2 divided by 0. So you have your 4 divided by 2, which is 2, right? Now that we have the value of I to be 2, you go back. Is 2 greater than 1? Yes. 2, then print out what? 2. Now 2 more 2 is what? 2 more 2 is 2 divided by 2. 1 remainder 0. Is 0 exactly 0? Yes. All right. So you have 2 divided by 2. 2 divided by 2 is what? 1. Now that we have 1, you go back. Is 1 greater than 1? No. That is how it will end. Is 1 greater than 1? No. So you cannot even move on to print 1. Why? Because it is not greater than 1. So apparently it's going to stop on 2 here. So that is how you read code and you see the flow of execution. Apparently in some interviews, you can meet this in maybe a current interview and all of that. And from that, you know how to read and execute things like this. Okay, we have covered a lot for today. Tomorrow, we'll be looking into... Yes, what we'll be looking into tomorrow. We won't do much on arrays because there's still another array. Okay, so we will be talking about mutable objects and designing classes. Apparently, we might even look more extensively, but tomorrow is going to be the end of Java class for now. We will talk more about methods and page object and all of that later on in the automation class. So it's not like it's an end of it, but at least the basics of Java that we are teaching here tomorrow is going to be an end of it. So try as much as possible not to just leave this thing as it is. It's easy to understand. It's also easy to forget. So it's easy to understand. You pick it and you're like, oh, I get it. But before you know it, if you're not practicing and all of that, it becomes also easy to forget. So please try as much as possible to practice. With this, we have come to the end of this class. Thank you guys so much for joining today.